All right, so let's go ahead and start the class, please. So first of all, before we start this topic, you know we had a test yesterday. I do have that graded already, and I will return that to you during the second period of today's lesson and then go over that. But for right now, I want to talk about polar coordinates. Okay, you'll notice that I also gave you some homework, sections 11.1, problems 1 through 11 all. Okay, that was already due today. Those were the very easiest problems from this section. So if you read it, those problems should have been very easy. The other problems, 12 through 34, are a little more challenging, but after today's lesson, they should be easy for you. And of course, you have 5 days to do it until you see me again, right? Okay, so let's talk about this. Polar coordinates. Now, luckily for you guys, this is a little different than previous years because the beginning of this chapter 11, which is all about polar, okay, you've actually done most of it, okay, with complex numbers, right? I mean, you've seen questions with complex numbers in polar form many times now. I mean, it was on your last test. It was on the test before that, and the one before that. It was on your midterm, right? I mean, you learned about it on Khan Academy when we were in the online phase. Okay, so just so you know, normally that would come after this topic. Okay, the only reason we're doing this now is just because when you guys were learning online and we had all those lessons in Khan Academy, for some reason Khan Academy didn't include that, so I knew that I could just wait and do it now. Okay, so this should be easy for you because it's very closely related to the polar form of complex numbers, but as you see, it's a little bit different. As a matter of fact, in some ways, it's even a little easier. So before we actually talk about polar coordinates, let's remind you of what you already know, which is the rectangular coordinate system. Now, the reason why we never called it that before is because it was the only coordinate system that you knew, okay? Basically, whenever you have a point, you can represent that point by 2 distances from the origin. You have your horizontal distance, which is usually called x, and you have your vertical distance, which is usually called y. Okay, so if I were to give you a point, let's say 2, 3, well, you just go 2 units to the right and 3 units up, and there's your point. Okay, so the same coordinate system that you've been using for years, that is called the rectangular coordinate system. Okay, the rectangular basically meaning left, right, up, down. Well, that's just one type of coordinate system. It's not the only type. Okay, so it's also possible to represent it different ways. And the one way we're going to talk about, of course, is using polar coordinates. So instead of having an x and a y, we're going to have an r and a theta. Now this r and theta are basically the same as the r and theta that you had for complex numbers. That's why I said you guys are a little bit ahead of this almost because you've already seen the r and theta. Now the only real difference is, first of all, there's no complex numbers, but also because the r for polar coordinates can actually be positive or negative, but for complex numbers, r was only positive. Okay? So it's real easy. So starting with the positive x-axis, and you know that's how we measure angles in standard position. So basically what you do is you just turn by theta degrees or theta radians, and then the r just says how far you go out. And that's where your point is. Okay, so it's a pretty easy system. Okay, imagine if you were going to, let's say, shoot a missile somewhere. Okay, if you think about it, the first thing you would do is aim, right? That's your angle. And then you want to know how far, right? And so basically that's polar coordinates. Okay, so let's see if we can locate some points using polar coordinates. Now, when you are graphing using polar coordinates, instead of having normal grid paper, okay, which has vertical lines and horizontal lines, basically we can have what's called a polar grid. Okay, so these lines right here correspond to angles. Matter of fact, this one looks to be about 30 degrees, right? Which is pi over 6. This one is 45 degrees, which is pi over 4.